This week we'll be discussing the atom, the elements, and the periodic table. As you likely know, atoms are composed of a positively charged nucleus surrounded by negatively charged electrons. The nucleus has a positive charge because it contains positively charged protons and neutrons, which are neutral. Hydrogen is the smallest atom, just one proton and one electron. Any one hydrogen atom is exactly the same as every other hydrogen atom, whether you find it in plastic, or water, or hydrogen gas, or water on Mars, or feeding fusion in the sun, or free-floating in space. Every hydrogen atom is also different from every other element in one way: the number of protons in the nucleus. We can change the number of electrons. A hydrogen atom without its electron is still a hydrogen atom, it's just an ion. Or we can change the number of neutrons. If we add 1 or 2 neutrons into the nucleus of a hydrogen atom, we sometimes call that deuterium or tritium, but it's still hydrogen. But if we add one more proton, now it becomes helium, a different element with fundamentally different chemical behaviors. The number of protons in the nucleus changes the charge on the nucleus, and that changes everything. To get an idea of the scale of atoms and their nuclei, let's move up to an atom with 79 protons in its nucleus, gold. So one gold atom is about 1/4 of a nanometer wide. So that's 1/4 of 1/1000th of 1 meter, which doesn't have a lot of meaning. It's hard to visualize. So that means that this millimeter gold bead would have 4 million gold atoms across. If a gold atom was as wide as this bead, then 1,000 atoms would be 1 meter wide, or about the same width as 5 chemistry textbooks. And 4 million gold atoms, or the width of this bead, would stretch over 4,000 meters, or 4 kilometers. And that's about as far as it is from where I am to RMC. So let's go. Okay, and 4 million. 4 million gold atoms. 4 million millimeters, actually. A lot more than that in gold atoms. So that's the size of one gold bead if each of the atoms in that gold bead was a millimeter large. Welcome to CMR, RMC. Okay, so if that's the size of the bead, if each one of the atoms was a millimeter, what would be the size of one atom if the nucleus was 1 millimeter? Well, as it happens, I have one set up just over here, so let's go check it out. Most of the volume of an atom is taken up by electrons. The outermost electrons are called valence electrons, and ours have a diameter of 10 meters. So let's zoom all the way in and try to find that nucleus. Okay, we'll just move in past the electrons. All this is mostly empty space anyway, so they're not really going to give us any trouble. And there we have it. There's the nucleus. That same 1 millimeter gold bead that we started with now forms the nucleus of this 10 meter wide atom. And it's the interactions between this nucleus and the other 99.99% of the space inside this atom that gives gold all of its chemical properties. And that's what we're going to be talking about for the rest of this week.